we've got our 4 little B 30 amp ESCs I'm going to be using for this build. This is the center plate I pulled out just to use as a reference. OSD, I'm going to wire another one up differently. This one's got the pins going out the wrong direction because, well, you'll see in a second. Flight controller, PDB. So pretty much everything's going to go on here. And if this is the bottom, it would be like this. Let's see, how do we want to do it? I think I'll do it like this. So the 5 volt and 12 volt pads are on one side here. Let me zoom in real quick. And because of that, you just have to keep in mind, if there's anything that's going to go to one side, that's going to be the side it's going to be off of. So as you put this in the quad, the 5 and 12 volt pads are going to be here. I suppose it doesn't matter. So my OSD is going to be here. Doesn't really matter, but if you're doing a build where it matters what side it's on, then just keep that in mind, and you may have to flip this. Likewise, the battery connections will be on the other side, so it's just something you have to keep in mind when you're doing this. And remember, it's all going to be upside down, so if you're doing it like this, planning it out, then when you flip it, you may run into an issue. So so it's going to be like this. OSD is going to be here, although different one with the pins facing forward. So it's going to be like this. And then while those are stuck on there, again with the 3M outdoor double-sided tape, this will be as far forward as it can go. Probably that USB will hang right off the edge of the carbon, and then the receiver will go right here. So pretty much everything goes on this one plate. And I mean, this would be great for this flight controller would be pretty good for like a 130 or 150. So now what's important is, so I may temporarily put this on here with double-sided tape, but this sits here. Ooh, camera. What's important is you've got to measure these and determine how long and where you're going to cut the power leads. So I really need to stick that on here with some temporary double-sided tape, and then I will place these the way they're going to go. Like this. Just go like this and then just kind of approximate. So it's going to be touching the, you know, like this. Take a Sharpie, draw where you need to cut it. Keeping in mind, and this is important, that one of these needs to be longer than the other. Because normally, like on this PDB, you've got plus on the right, your positive on the right, and your negative a little bit farther. Anyway, your negative wire has to be a little bit longer. So yeah, the negative wire has to be a little bit longer. So for each ESC, you got to make sure. And then on the other side, the positive wire has to be a little bit longer. So don't just cut them all the same length. And depending on whether you mount this a little bit farther back or forward, since I'm going to be mounting it farther back to make room for the OSD in the front, you know, the front and rear ones as well will have different lengths. So measure everything out first, and I will stick this on there and we'll measure it out. Okay, so next incremental step is I've taken the carbon plates out of the center of the frame. I've got my ESCs to the side. I'm trying to put together this center part, so I'm doing something a little bit differently. Normally, I put the OSD right in here, up against the side. But I found with this F3 board that you don't need to touch it. Once the OSD is in and it's got the firmware flash and everything, you don't really need to unplug it or anything, because with the old Afro Minis and the Naze Rev 5, and I'm not sure about the Rev 6 because I've never owned one, but with the Rev 5 and the Afro Mini, to connect it to USB using FTDI, oh, that's the other thing, Afro Mini does not have the USB port, so you had to use FTDI. So you would have to unplug the OSD, use the same, you know, 5 volt ground RX-TX cables, plug into the FTDI and connect. So that's why I had it up there, so for ease of connection. But with this Banggood F3 board, you don't have to do that. So unless you're flashing the firmware for the OSD itself, you really don't ever have to unplug it. So it can be out of sight. It can make for a tidier build. the thing is, I've just, this is the first time I'm trying this, so we'll see how it goes. So I've got this one ready to go. I've got the PDB on there, and then just in front of that I've got the OSD with a capacitor and the 6 pins I need to program it. And then I'm gonna end up just putting a video in and out, and then ground will be common ground. I've never had to put video ground, and so far it's worked for me, so I'm gonna do it that way. 1 second, make this a little bit brighter. There we go. So and this is another one. So the 2 frames I showed before, I'm actually gonna try to build them both at the same time. It'll take a little bit longer, but one for you and one for me, so they should be exactly the same. So this one, same thing, it's going to have this OSD sitting right there, and then once this is together, the flight controller will go right here, and then everything that needs to be accessed can be done through the front from the top of the frame using the the OSD. If that needs to be updated, unfortunately, I'll probably have to remove the FPV camera, but let's see if we can get this. There we go. But like I said, that doesn't get updated very often at all. So, I tend to do the flight controller firmware updates more often. So all that requires is sliding the camera forward and using my L-shaped right angle USB connector here. And so that can be done pretty easily. But the OSD, if that needs to be upgraded, well, you'll have to remove the FPV camera, which itself isn't really a huge deal. And the connector is pretty easy to get to, and the screws are just 2 on the side, so piece of cake. So I think this is the way it's going to be, because generally it's just going to be cleaner. So okay, see how that goes. Okay, so just for the heck of it, I loosely, so everything is loose, the frame's loose, but I did place it in there just to get an idea, make sure all the pins will fit, so there's clearance from the OSD pins to the standoff, and you can see this is how it will be updated from the front. If it needs to be updated, I've already programmed it. With all these electronics, I'll hook up the whatever I need to do to program it, and then I'll program it before I install it. Because if I had done all this, taped it up, and then tried to program it, and if it was a dud, you're just making more work for yourself, so you'd have to take it all apart. Same with the flight controller. I'm gonna first hook this up. This, in the past, I have had to have the bootloader connected, so I am gonna solder a 2-pin, like a servo connector, female, onto here, and then I can just use like a jumper bridge to connect it and boot it up. So the first time I flashed this, I did have to jump the bootloader, and instead of trying to fiddle with tweezers on these two little pins right there, I am just gonna solder a like a jumper cable, and then in the future that'll stick up near the top of the quad, hidden of course, but you can pull it out, and if you ever need to flash the firmware, it's very easy to jump that jumper cable, what I'm going to call a jumper wire, instead of trying to get to the bottom of this thing. Besides, once this is taped in there, you won't be able to get to those pads anyway. So, but I am going to flash this before I even solder anything to it, and try to put it into the quad. Of course, you don't want to do all that and then find out it doesn't work. So it's just one tip. On the Clean Flight firmware flasher page, load the firmware that you want for the SPF racing board target, and then choose no reboot sequence, flash on connect, manual baud rate 256,000. So as soon as it connects, this should try to flash. Okay, so this is kind of important, and if you're good at estimating, you probably don't have to mount the board inside to do this, but I am going to get exact measurements because I'm going to try to cut these wires as close as I can. So what I've done is I've installed the PDB plate in there with the PDB in there, obviously, and then I'm placing my ESC on here. So one thing I like to do is I like to label my ESC wires later, so that later you don't mix them up. If you mix them up, you're going to be chasing down why a motor spinning the wrong way, or if you put your props on, it'll like flip over or fly up in your face or whatever. So I'm starting with motor 1 and ESC 1. So I put a single mark with a Sharpie on the signal wire, and that tells me this is motor 1. And I should probably do the same with the ESC just so it's easy. And when I actually build it, you won't see it, so I'm just going to put a big 1 here, and then it'll get buried under the with the double-sided tape when I actually assemble it. But for now, so what I've done is I'm placing it, I'm holding it here there with my hand as close as I can to the frame, and then I'm going to measure these wires and place them there. I've probably made it a few millimeters too long, but I drew a mark where I'm going to cut the wire. So you have to do that basically for all. You don't just assume one will be the same for all of them. Let me see if I can shorten this a little bit. There we go, that's where I want to cut it. So because as I said before, on one side of the board, positive negative is different, and when you flip the ESC from this side, negative is that way and positive is this way. So you know, if you cut all the positives the same length, you're going to have an issue when you come back to this side. It may not reach. So do them separately. And then again, the front and the rear may actually have different lengths, so that kind of matters. And maybe to save you some time, I can just do this. So let's start with 1 from the edge of the board, centimeters or millimeters. The power lead for 1, probably have to cut. Now, you know, you may not want to take my word for this and do this yourself, but at least you'll be in the ballpark. For 1, it's 40, right around 44, 45 millimeters for positive, and negative is right around 45 to 46 millimeters is where I'm going to cut it. I'm going to go ahead and skip the 3 because 1 and 3 are the most similar. And again, yep, 44, 45 millimeters for positive. And for some reason I ended up with about 50 on negative. And I think because I wanted to come in at a slightly different angle on that one. So on 1 I would say give it an extra couple millimeters. So, but on 3 I'm at just about 50 millimeters. And then 2 on the positive, I ended up at, oh, I gotta pull this one out a little bit, 72. Yeah, right around 72 is where I put the little cut for the positive. For the negative, and this is from the edge of the board again, from the ESC board, and then for the negative is exactly 70. And for ESC 4, the positive is just shy of 70, like 68, and the negative ends up being 72, about 72. And again, it's just the way I've snaked these through, but you know, I did it one at a time, so I'm going to go with my own measurements. I'm going to trust them, and if you want to use those as starting points, so there you go. I just have to cut them and solder them, take the board out, solder them to the board, and of course at this point I have to take the frame apart. While I'm down there soldering, I'm going to solder up the flight controller. I'm going to put I'm going to feed off the 3.3 volt for the satellite that I'm going to use, and at the same time I'm going to create a little jumper thing here, and I'm going to have a plug sticking out somewhere in the frame so I can use the bootloader anytime I want. At the same time I'm going to put the 4 motor pins here. The power I'll probably direct solder, as well as the ground leads. Oh, while I'm soldering, I'm also going to shorten these signal cables, probably about 1 inch. I'm going to have to estimate those as well to see, because I don't want too much slag in there. And then I'm going to separate the ground and the signal lead. The ground I'm just going to cut. The signal lead I'm going to actually shorten and reuse the plug, and then put it in a 4x servo plug, and then that way I'll just plug all 4 signal leads for the motors at once. And if you don't understand that, well, you'll see it later. And I think that'll be pretty clean. Okay, so before I solder this up, or the power up, I want to be able to solder parts of the flight controller at the same time as the PDB. So before I do that, I want to make the wires on the flight controller as minimal as I can. So I have removed all the wires from these micro JST connectors, and a lot of these we're gonna splice. There's just no other way to do it and shorten the wires for like the satellite connector and etc. But here's where I am. So here's the bag of unnecessary wires that I just pulled out using a very small flat bladed screwdriver. You just pull up on the retaining thing and pull the wire out. It's just, don't bend it back too far. So this is where it's going to go. This is serial and ground. I'm going to use this for the satellite connector. Top one, the brown one, is serial, and the black one, obviously black is always ground. This next one here goes like this. And the 3 wires are from top to bottom: LED, buzzer, and VBAT. So this is going to go directly to a positive connection on the PDB. I'm going to use this for buzzer. I'm going to use a positive lead somewhere on a 5 volt. And then buzzer always connects ground. So when buzzer goes off, it grounds your buzzer connection. And sometimes you can use a 12 volt or even I've used a buzzer on 16 volt, and it's really loud, which is a good thing. But you just have to remember that if the current or whatever the wattage of the board can't handle a 16 volt and whatever the piezo buzzer pulls, that's why typically you go with 5 volt. Some people use 12 or 16 volt without problems, but I'm going to stick with the 5 volt on this one. So yeah, LED, buzzer, VBAT. And then on this side, orange and gray, that's channel 5 and 6, and that is RxTX for our soft serial for the OSD. I tried using the UART1, but it didn't work, so it's no big deal to use channel 5 and 6 for soft serial. You just have to remember to compile your your MWOSD with the right baud rate, which is like 19. It starts with 19. It's either 19200 or 19700. I think it's 19200. So I compile with that one, and then when you set it up with the GUI, you have to connect at that baud rate too. And then so 3 places before you compile in the config.h, and then in the GUI change it to 19200. I'll just use that number for now. And then in your soft serial setup in Betaflight or CleanFlight, whatever, you have to set that baud rate there too. Otherwise, this board won't be able to connect or communicate with your OSD. And those are the 3. I will probably snip these wires as I said, and then I will solder this up at the same time as the PDB, which I've already measured. I have to do these for the rest, but I just did one, so just to show how I'm doing this. The first thing is, thank you Dan for this tip. You don't have to cut the heat shrink. You can just heat it up, for 10 seconds or so on both sides. Peel it back real quick and watch your fingers, it will be hot. Peel it back on both sides, and then later on you can heat it up again. Even though it'll shrink, you can heat it up, peel it back to where it was, and then heat it and it'll reshrink. Does that save you time? I don't know, but instead of trying to find 1 inch or 3/4 inch or whatever heat shrink, you can just reuse. Now, when I was doing this, I did rip 3 of them, so there's 3 ESCs I will have to reshrink, but most of them came out pretty good. So, and then I removed the motor wires because we're going to be direct soldering wires from the motors onto these. And then I did one other thing. I took the signal wire out of the servo plug, and this one's got the tick mark for the motor number 1. I removed that, took it out of the servo plug. I left this one in there because I'm going to cut it later, so why bother taking it out? So I removed this one though, kept the wire, the plug, the whatever it's called, this connector pin on the end, desoldered it, before I did that, I placed it on the arm, snaked it through, held it up where the flight controller would be, gave myself some slack so that I could pull, because you can't have it just enough to go to the flight controller pins that are going to be there. You have to also have slack to be able to pull it out. So go through the motion of pretending to pull this out, and then that's how much wire you'll need. If you only give it enough wire to be really tight right up to the pin that I'm going to install, you may have problems actually just taking this out when you need to, and hopefully you'll never need to, but I've had that situation where I've had to take it out. So now I desoldered it, cut off a certain length, stripped a couple millimeters, and then soldered it back on after I measured it. So the length that I took off, in case you want to take a shortcut and not measure it, but I highly recommend you do just to verify, every build is different, is 64, maybe 65, no, more like 64 millimeters, but the wire is a little curly. So yeah, 64 to 65 millimeters I took off. Yeah, and that's it. It ended up being the same for the front and rear, because from the rear, the wire is going to go up and then come back, and then from the front, the wire is going to snake through, go up, and then come forward, kind of like a cobra. But it ended up being the same amount that I had to cut. So all the ESC wires for the signal, I'm going to shorten the same amount. But remember, the power leads are going to be different for the front 2 ESCs versus the 2 rear ESCs. Okay, so the PDB hasn't changed. I haven't done anything with that yet. I did allow the flight controller, so let's start with the bottom. Okay, just so happens those 2 pads are the boot pins, the boot pads, the bootloader pads. So when you first install the firmware, you have to short those. It's not too bad when you first install the firmware, because you've got this flight controller, in your hand on the desk or whatever. But once you install it, it's going to be facing down with the adhesive or double-sided tape, so it's going to be difficult to get to those. So I added this jumper. This is just a 2-pin servo. I guess this would be male. If you look at the plastic part, this is male. If you look at the metal pins, it's female, but I'm going to call it male. The male servo plug. I added that, and it goes across here. So all I need to do is add, stick a 2-pin prong in there and jump those or short them, or create a almost like a bind plug. Just create one that's got a double 2-pin shorted wire in there, really. But I've also got this this orange wire, because out of these 2 bootloader pads, the one on the left is also 3.3 volts, and I need that for the satellite. So that is this wire going across the flight controller, joined by ground and signal. So this makes up my satellite plug for Spectrum satellite. So that's that. Haven't done anything, and then I already explained this one. Haven't done anything with this one yet. This is going to be soft serial for the OSD. I'll probably shorten them. They just need to go to the front, right around here. And then this is, I haven't done anything with these yet either. This is a LED VBAT buzzer, then VBAT, I believe was the order. Won't matter, I'll look that up later. So I installed 4 pins for the motors at a slight angle, and you can see that angle here, just to make it easier to stick the motor wires, the signal wires in there, because at a slight angle I can just kind of shove it in, and those will probably never have to become unplugged. This is something I wasn't planning, so it is a 3-prong. Basically we just need 5-volt and ground. This is for transponders during a race, for timing systems, and the transponder usually ends in a 3-pin servo plug. I could have just used 2, because really you only need 5-volt and ground, but then if I use a 2-pin, it sits too low, and then the servo plug won't actually fit. So this 3rd pin, the 3-pin, the lowest one, is just a spacer, really. It's not going to be used, but it's necessary so that the servo plug can plug in without, issues. So that's the reason that's there. I will probably take the 5-volt pad off of this and go directly to one of these pads on here, ground and 5 volt, because this doesn't have the issue that Naze has, where you know the 5 volt is it causes problems with throttle ESC calibration. So it's going to be constantly connected, and I've done it before and it works fine. So, and then the motor's ground wires, I'll just bundle them into 1 or 2 bundles of wires, and then just ground them somewhere on the flight controller, because that's all you really need. So at this point, this is ready to be stuck to the other side of this. So I'm going to go ahead and do that, and then, as I keep saying, I'm going to solder these up. So I'll go ahead and solder the ESCs up first, then the any of the 12 volt or 5 volt. 12 volt will need 2 wires, one for the camera, one for the VTX. 5 volt will need 1, 2, at least 2, 1 to the flight controller, 1 to the OSD, and the LEDs I think I will grab off of the flight controller, and if not, I'll just grab it off of the 5 volt in the bottom. It's just that the pads are so small, so it may be difficult to put 3 wires on there. So before I stuck this on here, I wanted to show how I do the adhesive, the double-sided tape, that is. I don't want to, you know, there's things on here that make it lumpy, right? So I kind of go around it by doing it like this. 2 layers, and then these are the remnants. See? So I'll fold it over, then cut it to shape, and that way when I put it on there, we don't have any weird lumps. You want this to sit as about as flat as you can. Most important is that it doesn't move, but if it's off at a slight angle, the yaw is the most important. You don't want it on there twisted, so you want it on there pretty flat. So let's see if I can go ahead and stick this on here. I want the USB not touching any carbon because of weird grounding issues, and I want it centered as much as I can. You don't want it twisted in the yaw direction for sure. And I want to leave room for the satellite, which is going to go right there. So that should do it. Give it a good press. Just be careful not to press on the USB port or the pins too hard. Alright, that will be hard to remove. Trust me, this 3M stuff is, you know, you may have to pry up on the USB just to remove that. So there you go, and look at it. That's, I mean, not too many wires right now. It'll get a little bit messier, but that's, yeah, that'll work. So this will be satellite right here. Yeah. Alright.